first of easy का 7 ಇದೆ Good morning all the second year students. Today we will discuss about dose response relationship. Dose response relationship. There are two types. Dose response relationship, there are two types. One, graded response. Second, control response. Now you will see the graded response. The graded response, most of the drug magnitudes may be the vary of the drug, that is the intensity response increase the dose. This is called as the graded response. See, you can plot a graph. Dose versus effect. Now here is the effect. Dose is given in the percentage 20, 40, 60, 80 and 100%. Now here is the dose. Dose increase, the response is increased. That is called as the graded response. Now see that here is start from 0. See the dose is increased, response is increased. Then the point afterwards, dose increase and the response is the fall down. Response is a fall down. Now the dose and below is a log dose. Now see, start from 20% here, dose and then the response. Dose increase, response increase. Now this is the dose, this is the response. 1 ml, 2 ml, 1 ml, 4 ml, 8 ml and 10 ml. 4, 8, 1.6 ml, not 10, 1.6 ml. See, 1 ml dose is given. That response up to the 1 ml dose is given. Response goes to the 40%. Now here is a 2 ml dose is given. The response goes to the in between 80 and 60%. Similarly, dose increase, the response. Now see, a dose is a 4 ml. The response is maybe 80%. Then dose increase 8 ml. Dose is 8 ml. Response show the maximum. Here you show the maximum response. That point enzyme activity is maximum. You can say the optimum activity of the enzyme. Afterwards, dose increase, dose increase, the response is fall down. See, this goes to the 90%, then 8 ml dose goes to the 90%, 1.6 ml dose is increased and response is fall down. Response is come up to below 80. Response is came below 80. Then here dose increase and response fall down. What is graded response? The graded response, the magnitude of the response of most drug may vary with the dose of the drug. The magnitude is the vary of the most of the drug is vary, it is not the same. That is intensity of response increase, that is intensity of response with an increase in the dose. This is called graded response. This is called the graded response. However, the stage comes when any further dose increase, any further increase in the concentration of drug does not increase the response, Now see here the graph. 8 ml show dose is 8 ml, show the maximum response. Then further increase the dose. Now here further increase the dose, 1.6 is increased, response is not increased, response is fall down. Response is fall down, and again further increase the dose, again further increase the concentration of drug, response is fall down. Now 1.6 again you can go 3. then there goes the fall down. The graphical representation of graph dose versus effect is a shape or sigmoid shape. That graph is obtained. That is a S shape or sigmoid shape. That's the graph. According to the classical receptor occupancy theory, the magnitude of the effect is assumed that the magnitude effect is assumed to be directly proportional to the fractions of drug receptor occupied and produce maximum effect. And the receptor, they produce the maximum effect. That time is the drug is maximum receptor occupied and they produce the desired effect, maximum effect or optimum effect. These are the classic theory. The second, counter response. Now second response, dose response is the second counter response. The maximum drugs is produce the graded response. The maximum drug produce the graded response. However, there are some drugs. There are some drugs where observable response or values can be described in the term of an, see the important, all or non-response. This is called counter response. The example, death or no death. You understand now? See again the counter response. The counter response is the second type of the dose response curves. The maximum drug is produced, the graded response is the pharmacological response. The some drugs where observe the response can be desirable in the term, that is important, in the term all or non-response. The effect is produced all, otherwise नो इफेक्ट फॉर द ऑल. इफेक्ट इज प्रोड्यूस सबको आएगा, नहीं तो किसी को भी नहीं. दिस इज कॉल्ड एज द काउंटर रिस्पॉन्स. एग्जाम्पल, डेथ और नो डेथ. That is the dose response curves. Now second, you can see the definition. So many times is asked, but it's an important term, frequently is repeated. Biological half-life. What do you mean by the biological half-life? Biological half-life. The half-life of the drug, it can be defined as the time taken for its concentration to decrease to half of the original value. Now see the next is the biological half-life. Biological half-life, the half-life of the drug, it is defined as time taken for its concentration to decrease of the original value it had at start of time. It is always denoted by as, it is always written, it is always write t 1/2. It is always denoted is a t 1/2. The half-life for the different drug can give vary. It is not the same. It is sometimes it is a several minutes, sometimes is a day or longer. Example, half-life of the drug, half-life of the drug is vary. Sometimes it is having the some minutes, sometimes it produce the or days or longer periods. Example, the half-life. Now see the example. Example, penicillin G. It's a common example. Penicillin G is a half-life is 30 minutes. It's a common antibiotic. Second, aspirin, painkiller relief. Its half-life is a 4 hours. Decoxing, cardiac stimulant drug, is a half-life is a 40 hours. That is a vary. The all drug is not having the same half-life. But remember the half-life, the original concentration is decreased up to the half. That period is called as the half-life. There is most important parameter to the patient receiving the dose is most important. And then how much time is take to produce the effect, how much time they are having in the body. Penicillin G 30 minutes produce the half-life, aspirin 4 hours, decoxing 40 hours, they are having the half-life, and their duration of action is depend this. That is called the biological half-life. बंद करो.